Hello, welcome back to our lecture. In this part of the lecture, we're going to begin to talk about virtual private clouds or VPCs. A VPC is basically a logically isolated virtual network that exists within a region in AWS. And we can use this isolated virtual network to partition our resources. Essentially, a VPC is like having your own private data center. And it's like a private data center in the cloud that you completely control. You set up the entire networking topology, you set up the network routing, and then you can deploy your compute resources into it, and you have full control over all the security access to your virtual private cloud. And the real benefit of virtual private clouds is that it allows you to create these very secure application architectures and allows you to partition applications from one another within a single organizational account. And a VPC is absolutely critical to understand because basically all of the computing resources that you create have to live within a VPC. In fact, throughout this course, as you've been launching EC2 instances, whether you realize it or not, your instances have been have been launched into a virtual private cloud within the AWS region. Now, I've been teaching virtual private clouds to students over the past 2 years, and this is probably one of the most difficult concepts to understand in terms of AWS infrastructure. And I think it's difficult for some students to understand because they just don't have much of a networking background. And many of the concepts that we're going to focus on related to virtual private clouds are related to network infrastructure. Don't worry, I'll walk you through the process and I'll walk you through each element of a VPC so that you have an understanding of how all these different components fit together to allow us to create this isolated virtual network. Okay, so how do we use a VPC within an AWS region? In this diagram, I kind of show you a typical way where we would deploy a VPC. In this example, we have an AWS region, and within that region, we have defined a VPC. Within that VPC, you see multiple subnets, and the subnets allow us to partition the network address space within the VPC into smaller segments. Each subnet within the VPC has one or more EC2 instances. You can see how these EC2 instances, we have several of them that live in a public subnet, and those instances are behind an elastic load balancer. And then we see other instances, in this case database instances, that are in a private subnet. This is a very common topology that you find in VPCs, where a VPC contains multiple subnets, and some of those subnets might be considered public subnets that users from the internet might access. And then other subnets are private subnets, which contain maybe important data and databases. And those subnets cannot be accessed from the internet, but maybe those subnets can be, the private subnet can be accessed by resources that live in a public subnet. So when you create a VPC, you create that VPC in a specified region. And each region can contain multiple VPCs. There's a default limit that's initially in place in your account, and I think that default limit allows you to create at least 5 VPCs in any given region. When you create a VPC, you define a you define a privately routable network within that VPC. You can see in this case, here's a region, and this region has 3 VPCs. We have VPC A, then B, and C. And each VPC has its own privately routable network segment. For example, VPC A is using the network segment 172.16.0.0/16. This represents a large range of IP addresses that can be routed within this VPC. VPC-B has a separate set of a separate network range where it's 10.0.0.0/16. One note about private IPs, and this is for students that don't have a strong networking background. Most IP addresses are routable on the internet, meaning that if I have an IP address and you have an IP address and we're both connected to the internet, then we can route traffic between our two computer systems. However, there are certain ranges of IP addresses that are designated as private IP blocks. And these private address ranges are not routable on the internet. In other words, if you have a device and your device is assigned an IP address from one of these 3 ranges, your device will not be able to route data across the internet to other devices. These are non-routable IP addresses. We can, however, use these IP addresses within our organization, within our own private network. So as long as the traffic is contained within our organization, we can use these IP addresses and assign them to devices, and we can route data properly. But if that data needs to go across the internet, then we have to use publicly routable IP addresses. Now, because a VPC is a virtual private cloud, we use these private IP address ranges when we are creating our VPCs, which means that the data between the EC2 instances that live within our VPC, that data is only using private IP address ranges for routing purposes. The data communications between those devices is not transiting over the internet. So I mentioned earlier that a VPC can be further partitioned into multiple subnets. We assign a private network range when we create our VPC, and we can take that private network range and further partition it or break it down into multiple subnets. So here's an example where when we created the VPC was given a private IP address range of 10.0.0.0/16. We then created 2 subnets within that VPC. We have subnet 1 and subnet 2. Subnet 1 has a network range of 10.0.0.0/24. Subnet 2 has 10.0.1.0/24. These 2 subnet ranges fall within this 10.0.0.0/16 network range. We've basically carved out smaller network blocks and we've assigned those to each individual subnet. Each of these subnets within this particular VPC are associated with an availability zone. Subnet 1 is associated with availability zone A, and subnet 2 is associated with availability zone B. A subnet can only be associated with one availability zone. It's not possible to create a subnet which spans multiple availability zones. It's not possible to set up subnet 1 so that it uses availability zone A and availability zone B. A subnet must be associated with one availability zone. It's possible to create multiple subnets in any particular availability zone. I could have created both of these subnets and put them into availability zone A. That's just fine. Again, a subnet cannot span multiple availability zones. Each subnet that we create within a VPC is also associated with one routing table. The routing, and it's possible for multiple subnets to be associated with the same routing table, but each subnet is only associated with one. The routing table describes how data is routed within the subnets and within the VPC. The routing table describes the data routing rules. When we create EC2 instances, as I mentioned earlier, those instances are deployed into a VPC. And in fact, they're deployed into a specific subnet within a VPC. Every single EC2 instance that you create has its own private IP address. Every instance has to have at least one private IP address. Some instances that you launch may also have a dynamically assigned public IP address. And that public IP address is based on a subnet setting. So there's some instances that will have both a private IP address, which is absolutely required, and they may also optionally have a public IP address. Now, if an instance has a dynamically assigned public IP address, that public IP address is selected randomly from a general pool of available IP addresses. And each time the instance starts, the EC2 instance will receive a different public IP address. The instance private IP address will remain the same, but if it has a public IP address, its public IP address will change every single time it's started. Now, there are cases where you might want to assign a permanent public IP address to an EC2 instance. In other words, if an instance stops or is restarted, you don't want the public IP address associated with that instance to change. Well, in order to configure a permanent public IP address for an EC2 instance, you need to create what's called an elastic IP and then associate that elastic IP with the EC2 instance. One thing to note about these elastic IP addresses is that if you request an elastic IP address, but then you don't allocate it to an EC2 instance, then AWS will charge you a small monthly fee. I think it's around $1 per month for that elastic IP address allocation. or reservation in that case, because you actually haven't allocated it yet to an EC2 instance. And the reason they charge for that is because IP addresses are relatively scarce resources. There's only a finite number of IP addresses available in the world, or at least IP4 addresses are very limited at this point in time. And so if you reserve an elastic IP address, you really need to use it and apply it to your EC2 instance. Now, when you create an EC2 instance and you uh, you deploy it into a VPC and into a specific subnet within that VPC, the EC2 instance has a private IP address by default. Remember, every single EC2 instance has at least one private IP address. However, the EC2 instance can't route traffic over the internet using that private IP address. That instance is not accessible from the internet. It's not accessible from your laptop via that private IP address. In order to access that EC2 instance from the internet, that EC2 instance has to have a public IP address, and it has to be on a subnet that is able to route data through a resource called an internet gateway. An internet gateway allows a VPC to communicate to the internet. It allows traffic to transit between the internet and between resources that exist within the VPC. But remember, in order for a device on the internet to talk to an EC2 instance in the VPC, that EC2 instance needs to have a public IP address, and it needs to be on a subnet which is able to route traffic through the internet gateway. Now, AWS only allows you to create one internet gateway per VPC, which kind of makes sense. I'm not sure there'd be a real purpose for creating multiple internet gateways. These internet gateways are designed to automatically scale based on the traffic demands. There's no extra fee for using internet gateways. You're allowed to configure one internet gateway per VPC. And again, that just simply connects the VPC to the internet. Well, you might be asking yourself the question, well, what if I have an EC2 instance that lives in a private subnet within a VPC? And those EC2 instances, maybe there's something like database servers. These EC2 instances in the private subnet, of course, they have a private IP address because every EC2 instance must have a private IP address. But these instances in the private subnet do not have public IP addresses. How do these instances running in the private subnet, how would they communicate out to the internet? Well, there are some cases where you don't want them to communicate out to the internet. And in which case, you don't have to do anything to their configuration. They have a private IP address. They don't have a public IP address. The private subnet can't route out to the internet gateway because there's nothing in the private subnet routing table that's allowing traffic to route to the internet gateway. So these EC2 instances are effectively inaccessible from the internet. They are accessible from web servers and other other servers within the VPC, but they're not accessible from the internet. But what if these servers and the private subnet need to be able to make requests out to the internet? Maybe these private servers are making periodic requests to some sort of API service running somewhere on the internet. Maybe these servers need to be able to connect to Yum package repositories to download new Linux patches and security updates. Well, in order for these private EC2 instances to communicate with devices out on the internet, they need a little help. They need to they need to send traffic out to the internet through a device called a NAT gateway. A NAT stands for Network Address Translation. What a NAT gateway does is that it takes traffic from a private EC2 instance and then essentially sort of translates that traffic, or really proxies that traffic and sends that traffic out to the internet. The NAT gateway then receives a response from the internet device and then translates that traffic or proxies that traffic back to these private servers. So essentially, these private servers can send requests out to devices on the internet. The private servers can initiate communications, but internet devices cannot initiate communications to these private servers. There are a couple different ways to set up a NAT gateway. You could roll your own NAT gateway using readily available software running on an EC2 instance, or you can use a managed NAT gateway service provided by AWS. And the NAT gateway service is basically a service that's available like in EC2 instance, where you simply get charged for your utilization of the NAT gateway. There are some cases where you want to securely connect your office network to a VPC running in AWS. And to connect your office network to a VPC, you can use what's called a virtual private gateway, a VPG. A virtual private gateway is a VPN tunnel. It's a VPN connection that's created between a device on your organization's network, something like a network router or firewall system, and that tunnel is then permanently connected to a virtual private gateway resource that lives in your VPC. This allows you to securely transmit traffic and data between devices in your organization's network to EC2 instances that live within a VPC. Now, in an earlier lecture, we talked about security groups, and security groups allow you to create security rules which envelop your EC2 instances. Every EC2 instance that you create has to be associated with at least one security group. And those security groups, if you recall, those security groups are stateful, meaning that if your security group allows network traffic, incoming network traffic on port 80 to something like a web server EC2 instance, that web server EC2 instance is automatically allowed to communicate back to the internet device on port 80. So incoming port 80 traffic is stateful, and the response to that traffic is automatically allowed back out through the security group. So security groups are one way that we can create sort of firewall rules and security rules around our EC2 instances. Within a VPC, we also have another mechanism for filtering network traffic. And this is network traffic that is going to and from the subnets within the VPC. We can create specific access control lists, which filters the traffic out that is outside of the subnet. And this is traffic that is coming into the VPC that's trying to enter a subnet, and it's before the security groups. These access control lists rules are stateless, meaning that if you configure an access control list rule on a subnet and you are allowing port 80 traffic into the subnet, if you want port 80 traffic to also exit the subnet or egress the subnet, then you also have to specifically allow outgoing port 80 traffic as well. That has to be explicitly defined in the access control list. Now, by default, every subnet that you create has a default access control list rule, which allows all ingress and egress data. And essentially, there's really no access control list in place at all, because there's no filtering in place at all, because all traffic is allowed. Once you start creating access control list rules for your subnet, the very first time you create a rule, then it begins to filter all traffic which does not meet that rule. So it begins denying traffic unless it's explicitly allowed both ingress and egress from the subnet. I know this concept can be a little bit confusing, and so hopefully this diagram will help a little bit. We can look at and see how traffic flows through a VPC and when this traffic encounters the access control list and security group rules. So the traffic is coming through, if the traffic is originating on the internet, the traffic is coming through the internet gateway, and it's going through what's called the VPC router. This router is going to determine where to send the data based upon the routing tables that are in place in the VPC. Once the routing table determines that the traffic is going to go to subnet 1, the traffic is filtered through the network access control list associated with this subnet. If the traffic is allowed through the access control list to the subnet, then the traffic is going to be routed to one of the EC2 instances. At that point, the traffic has to be allowed through the security group which the EC2 instance is associated with. You can see how there's multiple layers here. The traffic has to first go through the network access control list, and then it might be filtered by the security group. If you have one instance in a VPC that needs to talk to another instance in the VPC in a completely different subnet, then that traffic is going out through a security group, out through the network access control list associated with the subnet, through the VPC router, then it's going back through another network access control list for the second subnet, and through another security group associated with the other instance. You have to you have to sort of keep this architecture in mind when you're considering how data is transiting from one EC2 instance to another EC2 instance. And oftentimes, many of the challenges that students experience in this course and during their assignments and in-class projects is they encounter a scenario where one instance can't communicate with another instance for some reason. In nearly every case, when a student encounters that sort of scenario, what is happening is that there's some configuration in in the security group rules that's blocking that communication. We don't use network access control lists very much in this course. In practice, in an industry, we'll use network access control lists. But in this course, we mostly focus on using security groups to filter out network traffic. So remember, anytime you encounter some sort of communication problem between two instances, it's almost certainly going to be something related to these security group rules. It could also, in some cases, be related to routing table rules as well, where one subnet is not able to route data to another subnet because of some sort of misconfiguration with the routing table. That's much less common, however, than some sort of configuration issue with the security groups. When you when you uh, when you create and set up VPCs, and when you launch EC2 instances into a VPC, you can select from one of three different tenancy options. By default, every EC2 instance that you launch runs on a shared hardware platform. In other words, your EC2 instance, which is a virtual machine, is running on the same hardware that other customers' virtual machines are running on. You're sharing the computing resources with other organizations. There might be some cases where the sharing of hardware just isn't tenable for your organization. In those cases, there might be cases where you want your own dedicated servers, your own dedicated physical hardware. And in those cases, when you launch an EC2 instance in a dedicated tenancy model, your EC2 instances are launched on servers that are dedicated and have been allocated to your organization and your organization only. You're no longer sharing the physical servers with other customers. And the last option is to run your instance on a dedicated host, meaning that you're gonna deploy an EC2 instance, and it's going to be the only instance running on that physical server. So it will be able to take advantage of all of the computing capacity available on that system. Now, these single tenant options, the dedicated host options, might help you meet certain security regulatory requirements, but you're going to pay a price for that. It's going to cost you at least minimum $2,000 per month per region just to deploy your first dedicated instance. So it's not an inexpensive way to deploy computing resources, but there might be cases where you're absolutely required to do it. And AWS provides this single tenancy option. Another feature of VPCs is that you can create multiple VPCs within a region, or even potentially across regions. Uh, and then you can you can set up what's called VPC peering to connect VPCs together. When you set up VPC peering between two VPCs, that allows you to route traffic from one VPC to another VPC. Remember, each VPC has its own private network, and typically that traffic can never leave the VPC. But if you set up a peering connection with another VPC, then the two VPCs can route traffic between each other on using their own private network address space. Now, there are a couple caveats with this VPC peering. First of all, if you want to connect two VPCs together via a peering connection, those VPCs have to have completely separate private network address space. Their private address space ranges cannot overlap. If they overlap, then you cannot set up a peering connection. The other caveat is that VPC peering does not support transitive communications, meaning that in this example, you see VPC B is connected to VPC A, and VPC A is also connected to VPC E. Well, it's not possible to route data from VPC B directly to VPC E through VPC A. The VPC peering connections are not transitive. You can't just route data across VPCs that way. So the recommended topology when you're peering VPCs is to create this sort of star topology where you have multiple VPCs all connecting back to a single VPC. Now, we've been launching EC2 instances for the past couple of weeks in this course. And I mentioned earlier that when you launch an EC2 instance, that EC2 instance has to be launched into a VPC and a specific subnet within the VPC. And you might be asking yourself, well, I never created a VPC. Earlier, when I launched an EC2 instance, that wasn't something I had to do. When you first set up your account with AWS, AWS creates a single default VPC for you in each AWS region. And that default VPC has an internet gateway and it has a set of subnets. And each subnet is configured to allow public traffic to route to it. That's why when you launch an EC2 instance, and you just select the default VPC and subnet setting, that EC2 instance is launched into the default VPC, and it automatically is given a public IP address, and you're able to shell into that EC2 instance remotely using its public IP address. The default VPC is set up for you as kind of like an easy learning tool. AWS is set up this default VPC environment to make it easy for you to create EC2 instances and terminal into them. The default VPC is a great learning tool when you're first starting to use AWS, but it's not generally appropriate for production use. When we build applications in our organization and we deploy those applications on AWS, we pretty much always want to create our own VPC. And we want to tailor the security settings of that VPC for our specific requirements. The default VPC is just too insecure in most cases to deploy production resources into. And oftentimes we'll go ahead and either either sort of disable that default VPC, we'll remove it, or we'll go in there and we'll remove like all the subnets, and we'll greatly reduce, and we'll put access control lists in place to basically render the default VPC useless in a production environment. That's so that if somebody accidentally launched an EC2 instance into the default VPC, that instance wouldn't become immediately and potentially accessible from the internet. Okay, at this point, I'm going to do a demo of some of these VPC components so you can begin to understand how these components are sort of glued together and how we go about creating a VPC from scratch and then building it up with subnets and routing tables, and how do we configure NAT gateways and internet gateways and so on. And this is something that I'll have you do in some of our class projects, and you'll need to be able to do it in the assignment. And it's important to understand how all these components are created and how they're all pieced together, because in the real world, and when we're deploying applications, everything we're all the resources we're deploying are deployed into these VPCs. And if we're trying to troubleshoot problems, we really have to know how all these components work together within a VPC environment. Okay, this VPC hands-on demo is something I strongly recommend following along with on your own laptop and in your own AWS account. And you might have to sort of pause this video in certain places just so you can kind of uh, keep up with me as I go through these processes. And don't be afraid to try this process a few times. You'll have to do this in-class projects and on some of your assignments. And I want you to become familiar with and comfortable with this process and have a good understanding of how all these components are assembled. I'm going to go to my AWS dashboard. I've already logged into my AWS account, and I'm going to go to the VPC service within AWS. And in the VPC service, I'm going to click on this link that says your VPCs. And you'll see that there's already one defined. If I scroll this grid to the right, you'll see that there's this default VPC column here, which specifies which of the VPCs is the default VPC. And of course, the first and only VPC in this region is the default VPC. Every time I launch an EC2 instance, it's going to be associated with this particular VPC unless I specify otherwise. Let's go ahead and create a new VPC within the region. And I do that by clicking on the Create VPC button. I click on Create VPC, and I'm going to give my VPC a name. I'm going to call it Class VPC. And I need to assign the VPC an IP version 4 Cedar block, which is the network address range. In this case, I'm going to use the address range 10.0.0.0/18. The /18 part of this block describes how large of a subnet I'm going to create. I can select the default tenancy option for EC2 instances in this VPC. Again, I'm just going to use the default. If you select the dedicated option, then you might end up maxing out your credit card this month. So I recommend just keeping it on the default option. I'm going to go ahead and say yes, create. And AWS will go ahead and create my new VPC called the class VPC. And each VPC has its own unique ID that you see here. Okay, so I have my VPC and I've defined the private network address range that is going to be allocated to this virtual private cloud. Now I want to partition my virtual private cloud, my VPC, into two different subnets. I want one subnet to be a public subnet, and I want the other subnet to be a private subnet. I do that by clicking on the subnets link. And I then click on, and you see a bunch of subnets here. All of these subnets you can see are associated with the same VPC. These are the subnets which were set up for that default VPC. One subnet in each availability zone in this region, which is the North Virginia US East 1 region. I'm going to go ahead and create a new subnet. And I'm going to give that subnet a name. I'm going to call it the class-public subnet. And I want to make sure I select the new VPC I created. I want to associate it with my class VPC. At this point, I can also associate this class public subnet with a particular availability zone. It doesn't really matter which availability zones you associate it with. You just need to associate each individual subnet with a different availability zone. I'm going to associate this one with US East 1A. And then I need to assign and allocate another network block, a seeder block, to this class public subnet. And remember, this network block that I assign to and allocate to the subnet has to be part of the VPC's address range. I'm going to choose 10.0.1.0/24 and then click on the Yes Create button. And now my subnet has been created. I'll go ahead and quickly do the same thing for the private subnet. I'll call it class private and associate it with my class VPC. Availability zone, I'll just use US East 1B this time, and then give it a different network address range, which is also a portion of the VPC's allocated network range. Say yes, create. And now I have my class private subnet. Let me ask you a question. Is this class public subnet, is this really a public subnet? And this class private, is this really a private subnet? Meaning that if I launch an EC2 instance on the public subnet, is that instance going to be available from the internet? Well, just because I call a subnet a class public subnet and a subnet the class private subnet doesn't actually mean that this is a public or a private subnet. I would have to make other configuration changes to and set up the routing tables properly and set up public IP addressing properly to make these either a public or private subnet. Just the fact that I gave them these particular names doesn't mean that they're public and private, in other words. This is just a handy reference for me so I can remember that, okay, I configured this, I named this subnet a public subnet, and I'm going to configure it so that it allows public traffic to transit to it. And this one is a private subnet. Okay, so each of these subnets that we created is associated with a routing table. Remember, every subnet has to be associated with one routing table. And it's possible for multiple subnets to be associated with the same routing table. And right now, these two subnets share the same routing table. If I scroll over here, you can see this class VPC, the private one has this routing table ID, and it's the same routing table ID as the public subnet. Well, let's go ahead and take a look at that routing table. I could do that by clicking on the routing tables link. And here's the routing table that was set up for the class VPC. Note that I didn't actually create this routing table. This routing table was automatically created for me when I created the VPC. When I create a VPC, AWS will set up a single routing table called the main routing table. You can see there's a column here which says main, and this routing table is considered, is denoted as the main routing table for the VPC. If I click on this routing table and then look at the routes associated with the routing table by clicking on the routes tab, you'll see that there's only one routing rule in place. And the way to read this routing rule is that any traffic which is destined for any IP address in this network range, which is the entire VPC network, any traffic which is destined for this will flow through the local router within the VPC. Essentially, what this means is that any EC2 instance within the VPC is able to route traffic to any other instance within the VPC. As long as the security groups that each EC2 instance is associated with, as long as those security groups aren't going to filter that traffic, and as long as the access control lists on subnets don't filter the traffic will be routed between any EC2 instance with the VPC because of this rule. And each one of the subnets that we created is associated with this main routing table. I clicked on the Subnet Associations tab, and you can see that these two subnets are here. Actually, it says that you don't have any subnet associations. Well, with this caveat, it says the following subnets have not been explicitly associated with any route table and are therefore associated with the main routing table. So in other words, I didn't explicitly assign the two subnets that I created to the main routing table. But because I didn't explicitly associate these subnets with a routing table, by default, they will be associated with the main routing table. So that's something to keep in mind, and you'll see that come into play here shortly. Okay, well, right now we have a VPC, and that VPC has two subnets, and the subnets are both associated with the same routing table. What would happen if I went to the EC2 dashboard and launched a new EC2 instance. I selected my class VPC in one of the subnets and launched that EC2 instance into it. Would I be able to access that EC2 instance from the internet? What if that EC2 instance had a public IP address? Well, I wouldn't be able to access any of these EC2 instances from the internet. And that's because we haven't allocated or we haven't created an internet gateway for our VPC. Let's go ahead and do that now. I can do that by clicking on the Internet Gateways link in the dashboard. And I can say Create Internet Gateway. Click on the Create Internet Gateway button. I'm going to give my Internet Gateway a name. I'll just call it Class-Internet Gateway, or IG. Say Yes, Create. I've now created a new Internet Gateway, but that Internet Gateway is in a detached state. In other words, the Internet Gateway hasn't been attached to my new VPC yet. Let's go ahead and fix that. I select the class Internet Gateway, and I click on the Attach to VPC button. And then I can select my new class VPC. You can see it, in this case, it's already selected for me. And then I click on the Yes Attach button. Now my Internet Gateway is attached to my VPC. It's now possible to route traffic from the internet to my VPC and vice versa. Now, you might be wondering, well, if you launch an EC2 instance now at this point, will you be able to connect to that EC2 instance from the internet? What do you think? Well, the answer is not quite yet. Even though we've created an internet gateway and we've attached it to the VPC, we still can't communicate with an EC2 instance that's launched into one of those subnets. And that's because we need to explicitly set up a route within the routing table to allow traffic from the subnet to go out, to configure traffic that is leaving the subnet to go through the internet gateway in order to communicate with devices out on the internet. And let's go ahead and do that. Well, I'm going to go back to the routing table that we had set up. And here's the routing table. It's associated with our class VPC. And I'm going to click on the Routes tab. And what I want to do is I want to edit the routes and add a new route. Add another route that tells the subnet how to route traffic out to the internet. In this case, the destination for that traffic is going to be the internet, which is represented by 0.0.0.0/0. That means basically everything in the world. And I want to route that traffic through an internet gateway. Now, when I click on this field here in the target column, you can see that I can select my internet gateway as a target for this routing rule. I now click Save. And now I can route traffic between the subnets that are using this routing table and the internet, and vice versa. Now, at this point, if I launch an EC2 instance, and that EC2 instance, and I launch it and associate it with this new VPC, and I associate it and configure it to launch in one of the subnets, and I give that EC2 instance a public IP address, I will be able to access that instance from the internet. I'll be able to shell into it from the internet as long as the security group rules are set up properly. Well, you might be noticing that there's a problem with this configuration. And the problem is that I set up two subnets. I called one subnet my public subnet, and the other subnet I called my private subnet. I, I wanted to configure these subnets so that we could access resources in the public subnet from the internet. But I didn't want resources running in the private subnet to be accessible from the internet. Well, it's the problem is that if I click on subnet associations, both of these subnets, the class public and class private subnets, are using the same routing table, meaning that I'm allowing traffic to route potentially from the internet to my private subnet. I don't want that to be the case. So to prevent that from happening, what I'm going to do is I'm going to create another routing table. And I'm going to just call this my private class routing table. And I will associate it with my class VPC and go ahead and create that private class routing table. When I do that, you look at the routes, you can see that AWS automatically set up this sort of default route for me, which allows all traffic to be routed within the VPC, which is fine. I want to allow traffic to route from instances running in the public subnet to instances running in the private subnet. Now, the next thing I want to do is click on the Subnet Associations tab, and I want to associate the private subnet with this new routing table. So I click Edit, and I'm going to associate the private subnet with this routing table. And click Save. And now you can see the private subnet is associated with this routing table. If I go back to my other routing table, which is, remember, this is what's called the main routing table. If I go back to this routing table, you can see that this class public subnet is associated with it. I can make this association even more explicit by selecting that subnet and explicitly associating it with this main routing table. I think it just makes it a little bit more clear. Okay, we now have two routing tables in our VPC, and one routing table is allowing traffic to flow out to the internet through the internet gateway. And our private routing table only allows traffic to be routed within the VPC. If I launch an EC2 instance into the private subnet, it can only communicate with other EC2 instances within the VPC. There's no way it can communicate out to the internet. Well, how can we change that? How can we set up a way for an EC2 instance running in the private subnet to be able to make requests out to services and APIs that live somewhere on the internet? We can do that by configuring a NAT gateway. Let's go ahead and do that now. I'm going to click on the NAT gateways link, and I'm going to say click on the Create NAT Gateway button. Now, it's going to ask me which subnet I want to launch this NAT gateway into. I want to, and I need to launch this NAT gateway into the public subnet. Why does the NAT gateway need to be in the public subnet? Well, because the public subnet is the only subnet right now which can communicate out to the internet, because I set up a routing table rule which allows traffic to route from the public subnet through the internet gateway and out to the internet. So the NAT gateway has to live in that public subnet. The next thing I need to do is I need to allocate an elastic IP address to the NAT gateway. The NAT gateways have to have static public IP addresses, which means you need to have a elastic IP. I don't have any elastic IPs that are available, so I'm going to create a new elastic IP. And I do that, it automatically creates a new elastic IP and sets it in this form for me. Next, I'm going to create a NAT gateway by clicking the Create NAT Gateway button. I'm going to close that and look at the NAT Gateway dashboard, and you can see that it's currently creating a NAT gateway for me. Now, launching a NAT gateway is kind of like launching an EC2 instance. So, it's going to take a minute or two before that NAT gateway is available to us. In the meantime, I need to go make a change to my routing table to allow my private subnet to route traffic through the NAT gateway out to the internet. I'm going to go back to routing tables, and I already have the private class routing table selected. I'm going to go and edit the routes for this routing table, and I want to add another route. In this case, again, I want to route traffic out to the internet, 0.0.0.0/0. And my target isn't going to be the internet gateway in this case. I want traffic from the private subnet to be routed through that NAT gateway that I've created, because that NAT gateway is providing an additional security layer for me. So I select the NAT gateway as my target route. And I go ahead and save. Let's go back here and see our NAT gateway is still pending. Again, it's going to take a couple minutes to be up and running, but I'm sure that'll happen shortly. So, but in the meantime, we're at a point now where we can begin launching EC2 instances into our VPC. So take a step back and think about what we've done so far. We have created this VPC, or this virtual private cloud environment. It has its own private network address space. We've partitioned that private network address space into multiple subnets, into multiple segments. We're calling one segment our public subnet, the other one our private subnet. And each subnet is associated with its own routing table. And the routing table has a set of rules which describe how data is routed within the VPC, and how data and how those EC2 instances running those subnets, how they communicate out to the internet. In our public subnet, the EC2 instances are communicating to the internet through the internet gateway directly. In the private subnet, the EC2 instances are going through a NAT gateway. That NAT gateway is sending traffic through the internet gateway and then out to the internet. That's how things look so far. Let's go then to the EC2 dashboard, and we're going to create a couple EC2 instances. I'm going to go ahead and launch an instance. And we'll just use our standard Amazon Linux AMI. It'll be a T2 micro instance type. Go ahead and configure instance details. And so far, when you've been launching EC2 instances, you've been mostly ignoring these particular configuration settings. But from this point forward, we'll be modifying these configuration settings in most instances that we launch. When we launch this EC2 instance, we specify which VPC we're launching it into. And you see that by default, the dashboard has the default VPC selected. I want to launch this into the class VPC. And we also then select the subnet that we're going to launch this EC2 instance into. I want to launch this EC2 instance into the class public subnet, which is already selected for me. In terms of, and then we can specify whether or not we want to auto assign a public IP address. I want to assign a public IP address to this EC2 instance. And that's because I plan to shell into this instance remotely from the internet, from my laptop. All the other settings we're going to leave to their default, and we're going to click on Next, Add Storage. We'll also leave this at its default. Next, add tags. We're going to add a tag called name, and we'll call it we'll just say that this is our public server. Next, configure a security group. I'm just going to use this default security group that's automatically generated by AWS. It has a single rule allowing SSH traffic in from the internet, which is fine for now. I'm going to review and launch. Everything looks good. Go ahead and launch this and select an existing key pair. Acknowledge that I have access to that key pair and launch the instance. Okay, I have that instance, this new instance, which is launching. I'm going to go ahead and while that one's launching, I'm going to create another one. Again, using Amazon Linux, AMI, T2 Micro. I'm going to launch this second instance into the class VPC, but I want to launch this one into the private subnet within the VPC. And I'm not going to auto assign a public IP address. The second EC2 instance will only have a private IP address. It will not have a public IP address. If I assigned it a public IP address, would I be able to connect to that instance from the internet? No. Even though I assigned it a public IP address, I'm launching it into the private subnet. And the private subnet is not directly connected to the internet gateway. So I would not be able to access the instance directly from the internet through the internet gateway. I would not be able to do that. Okay. I've disabled auto assigning public IP. All the rest of the settings are fine. Under storage, I'm just going to accept the defaults. I'm going to add a tag called name, and this one will be the private server. Configure security group, and what I'm going to do for the security group is I'm going to allow SSH traffic. I don't want to allow it from the entire internet, but I will allow it from the security group that I created previously, which was this Launch Wizard 7 security group. By the way, and I'll do this in future demos, it's actually a better practice to specifically name the security groups because it's just easier to remember. I remember that the security group 7 was, or the Launch Wizard 7 was the security group which was set up for that previous instance. So I'll select that as the source. This security group rule is basically saying that the only devices that can SSH into this EC2 instance are those EC2 instances that live in that are associated with that other security group. I'm going to go ahead and review and launch, and everything looks good. So I'll go ahead and launch, select my existing key pair, and say, yep, that all looks good. And I'll go ahead and launch that second instance. And I'll pause here for a moment while these instances are starting up. Both of my EC2 instances are up and running. I'm going to go ahead and shell into the public EC2 instance. So I select the public IP address for that instance, and I go to a terminal shell and say, oh, before I shell into this server, what I'm going to do is I'm going to shell into the public server, and from there, I'm going to shell into the private server because I can't access the private server directly from the internet. I can't shell into it directly. It doesn't have a public IP address. It's in a private subnet, which is not able to route traffic directly through the internet gateway. So in order to access that private server remotely, I have to first log into the public server and use that as sort of a what we call a jump box or bastion host to log into the private server. And I do that using a feature within SSH, and I can add an SSH key to the SSH, what's called the SSH agent, a really handy feature. I'll go ahead and add my key to this agent, and you'll see how this comes into play shortly. I'm going to SSH into the public server. I'm going to pass in this -a argument, which means I want to use the agent when I access that server. And I'll go ahead and shell into that server. So now I've logged into the public server. And of course, I'm able to access the public server just fine from the internet because it has a public IP address. It's on a public subnet. Now I want to be able to access that private server. But remember that I click on the private server, you see the settings. There is no public IP address. It is not accessible from the internet. It does, however, have a private IP address. And what I want to try to do is access that private server on its private IP address. So I do SSH ec2-user at private IP address. And now I have shelled into that private server from the public server. And this is a pretty common pattern that you find. It's typical that, if you want to access a private server like this, you need to go through some other server first. And again, that's what we call a bastion host, or sometimes they're called a jump box. Well, let's make sure that that private server can access the internet. So I do a sudo yum update. And sure enough, that private server is able to communicate out to the package management repositories on the internet and download and retrieve new packages, new software packages. So the fact that I'm able to do a yum update proves that the private server is able to make requests out to services running on the internet. And so that's the completion of the demo for this lecture. I know this was a longer lecture. There's a lot of material in here. You might need to go through it a few times and pause it a few times. I strongly recommend trying to do this hands-on segment using your own account, and you'll get plenty of practice doing this over the next coming weeks. And as I mentioned earlier, it's very important that you have a clear understanding of each one of these components and how they all fit and work together within a VPC.